quick review for the subject. Solid waste engineering and management. So the municipal solid waste is a useless or unwanted material discarded as a result of human or animal activity. And if you talk about the management involves the functional elements, start from a generation, separation, collection, transfer and transport and disposal of a municipal solid waste by considering some of the factors. What are those factors are there? By accounting the public health, which is the foremost target, considering the economics, conservation, aesthetics and environment, and is responsive to the public demand. So the municipal solid waste management refers to the activity in process undertake reduction to the effects on the health caused by the improper management or the disposal of a waste. So what is the major target? The major target is the human health. We have to manage the municipal solid waste so that it will not harm to the human health. Now, in addition to the human health, we have to also consider the environment, means a biotic environment, the rest of the other environment. First of all, we have to consider the human health. Second, we consider the rest of the environmental factors, considering the biotic and abiotic, considering the water bodies, considering the land, considering the underground water, considering the surface water, considering the animals, all of them as the second priority. And the third priority will be considered as the aesthetics. A good looking, pleasantly looking, not looking at as a bad. Now, these are some issues related with the municipal solid waste, starting from the generation, waste minimization, waste removal, how we remove the waste material, transportation of a waste treat, what methods will be considered for treating of waste. We have covered the 4 functional elements. The 5th one is the processing, in which the major work is the treatment. Also include the recycling and reuse, storage, collection, transfer and transport, treatment of a leachate or the byproducts, landfill disposal. Ultimately, if you go for the disposal, if you go for the management of a waste material, we take any of the route. So ultimately, we have some quantity of a waste left that we have to dispose of. For example, if you go for the incineration, after the incineration we have ash available. And then some environmental considerations are there, ended with the education and training for the better exposure for the management. If we talk about the management practices, they vary. They vary from countries to countries. Poor and a rich country, region, from urban to the rural, it's varied. And even a sector, if you talk about the residential or industrial sector, it's a variable. Now these are some glimpses for the present scenario for the municipal solid waste in the poor country like Pakistan. We sometimes call it developing country. But the developing countries are poor as compared to the developed countries. This is the collection mechanism for hand trolleys and disposal discarding along the roadside. Some better systems are also available. In the developed countries, we have a proper collection system is available, though we have some proper collection system available in some residential areas. They have automated collection vehicles, clean roads. We have also a recycling. The scavengers collect the waste material from the waste piles, storage containers. Whereas in developed country, they use bale conveyors, specific places where the waste is being sorted. waste material burning, open dumps, whereas we can go for the same burning in the closed enclosure at the higher temperature to achieve the incineration for the waste material, which can cause a result in the generation of the heat energy, which can utilize for producing the steam and power. That's a gasification plant. The animal breeding is not so advanced, though we have some farms are there which are following the modern practices, but not majority of them. Let's talk about the slaughterhouses. So we have abundance of a slaughterhouse waste. This can be controlled if you have proper slaughterhouses, and the waste can be disposed of easily. Another, we have agriculture waste. Some quantity of agriculture waste, we burn it into the stove for the cooking, including the rice straw, cotton stalks. These are the two major. Even the canola straw are also used for the cooking. But it is observed that some major quantity of agriculture waste is also burned into the field without any proper use. In addition to the energy, we can also get a raw material from the agriculture waste. Like this rice is used as an insulating material during the construction of a house. Or we can convert the raw materials into the pellets through the pelletizers. So such a pelletizer machine is available at the USB Custom, and the stove is available over here. We have a stove available. Some of the students from the previous batches have developed some different stove. At present, one of the students of our masters is working also on making the briquettes. Briquettes are larger from these pellets. Briquettes by carbonization of agriculture waste. So abundantly we say that the waste material from the different resources is like a monster to the environment. So we have to control it. And we have set the priority. The priority is human health, then rest of the environment, then consider the aesthetics. These are the different components of a waste material, like high grade paper, mixed paper, corrugated, yard waste, food waste, glass, plastic, ferrous and non-ferrous metals, then the wood, rubber, textile, and the miscellaneous. The miscellaneous major portion is the ashes and the dust, dirt, which is available in the municipal solid waste. Then we have functional elements. These are 6 functional elements. The whole subject comprises studying these functional elements. These functional elements are starting from a waste generation, storage, and collection. So up to here we have a straight path. After the collection, waste is being collected. Then we have 3 parts available. The first and simple path is that the material will send to the disposal site. Second part is that if the cost of a transport is high, so the material is transferred from smaller vehicles to the larger vehicle and then transported to the disposal site. Or after the transfer and transport, or after the collection, the material can be sent to the processing and recovery. Processes and recovery involves material sorting into the different categories, and then some process will occur either to manufacture the raw material for the new material to be produced, or the ultimate target is to get the energy. So either we consider the raw material or energy. The 2 targets are there in the processing and recovery. If we talk about the hierarchy of solid waste, the At present, what is the general practice? The general practice is that tip of the this pyramid is a very small. So a very small quantity of solid waste is being prevented, so that solid waste will not be generated. Followed by a larger quantity in the minimization, then reuse, recycle, recovery of energy, and finally the disposal. So much quantity of a waste material, solid waste, at present is being disposed of. Whereas the best management practice is considered as the source reduction is at the higher level. So this pyramid is the inverse pyramid: source reduction, reuse, recycle, resource recovery, incineration, and the landfill should be minimized. So the pyramid practice is to be implemented in order to get the target for the municipal solid waste management. In the second presentation, we have talked about the physical characterization of a solid waste. In the physical characterization, these are the functional elements. We will talk about the waste generation. In the waste generation, there are several parts. One of the part is the physical characterization. The physical characterization involves some of the parameters like quantity of waste, how much waste is being generated. Unless we don't have a total quantity, we are unable to manage the rest of the functions. We are unable to manage the solid waste. In addition to the quantity, we also require the composition of our waste. This is called a physical characterization, that what components are available in the municipal solid waste. That how much quantity of a paper is available, how much quantity of a tin, plastic, and the yard waste and the organic waste is available as in total. The quantity can be associated if we are able to calculate the waste generation rate, which can be expressed for the residential area as that how many kilograms of a waste is generated by one person in a one day. We call it a waste generation rate. If we come to know the waste generation rate, then we can multiply with the total population available to the area, then a total quantity can be considered. Similarly, waste generation rate can be associated with the composition also, that how much paper is being generated by one person in a one day. So if we talk about the physical characterization, we have a waste, the physical characterization depends on the waste sources, types, waste generation rates, and waste composition. Now this is the classification of a solid waste based on the type. We have a garbage. If you talk about the garbage, that means waste from the preparation, cooking, and serving of a food. Market refused, waste from the market, waste from the handling, storage, and the sale of processed produce and meat, either be at the slaughterhouses or open ware. So all these activities are being considered as in a garbage. What are the sources are there? The source for these three types of waste is households, institutes, commercial concerns, hotels, stores, restaurants, and markets. We can also classify the solid waste as a type as a combustible and non-combustible. The material which will burn on the ignition is combustible. Some materials are combustible, some materials are not combustible. Like if you talk about the metals are not combustible. They will not give you the heat energy while you burn them. In spite of there are some materials which are highly burnable, like a plastic, paper, cardboard. These are burnable components. Then we have ashes. Ashes means the leftover after the burning. The ash also includes some quantity of dirt in it. Then we have a bulky waste. The bulky related with the volume and the weight. They have a higher volume and higher weight components like refrigerators, stoves, tires, appliances, furnitures. Then we have a street waste, like a street sweepings. You come to know that street sweeping is the part of a waste collection. Dirt, leaves, dead animals. Then we have abandoned vehicles, and then we have one special type of a waste, which is a construction and demolition waste, available to the sites where there is a construction and demolition. So its availability is not constant. Then we have industrial waste, depending on the type of industry. The steel industry will generate this the waste material related as a byproduct or from the raw material. Then we have a hazardous waste, which includes the pathogenic waste, or the waste is explosive, which can cause explosion, or the waste is having the radioactive property, emits a rhesus. The hazardous waste also includes the materials which are acidic or alkaline, highly acidic and highly alkaline. All the materials are acidic or alkaline, but if they are highly acidic or highly alkaline, even then they come into the hazardous waste. So in this subject we do not talk about much about the hazardous waste, because in the final year you have a separate subject for the hazardous waste management. Then we have animal and agricultural waste, including the manures and the crop residue. These are not generally the part of municipal solid waste, but sometimes they become a part if the animals or the agriculture products are available into the municipalities. Then we have a sewage treatment. After treatment of a sewage, we have a solid material left. We also consider that as a part of a solid waste. Another classification of a municipal solid waste, we classify them into the either the material is biodegradable or non-biodegradable. The biodegradable, which are being consumed by the bacteria as a food. As a result, they produces the carbon dioxide in other gases. And non-biodegradable are those which are not being consumed by the bacteria as a food, and they do not degrade. So different components are there. If you talk about the plastics nowadays plastics are also available as a biodegradable material. So we have a separate biodegradable plastic and non-biodegradable. As in general, biodegradable means paper, food waste, vegetables, fruits, even a wood is biodegradable. But the biodegradability is not same for all the materials. And on the non-biodegradability, we have a plastic, glass, and metal. If we talk about the biodegradability, look into the biodegradability of the wood is about 15 years. So much time is required to degrade in respect in comparison to the organic materials like a food, fruits, and vegetable waste. They requires a 1 week or a 2 to degrade. And non-biodegradable are the metals, including the tin, aluminum. If you talk about the steel, even mild steel, it deteriorates with the passage of time. Or it's like a plastic. The glass bottles are generally considered as a non-biodegradable. Now, what are the sources are there, including the types? Now, this classification is based on the source. If you have a residential area, what type of a waste are available? So there's a reversal process. Previously, we have talked about what components, what is a major characteristic, where it is being found. Now we say that in a residential, what components are available? In the industrial, what components are available? If you talk about the commercial, what type of available? In the institutes, what type of components are available? In the construction demolition waste, what type of waste is available over there? Municipal services and the processes, what type of components are available to these sources? Now this information will be helpful while we are considering the waste management system for any area. If you are considering the waste management system where only the residential areas are there, So these components can be expected. But in addition to the residential area, we have a construction and demolition waste. We also consider wood, steel, concrete, dirt, and these components are also the part of a solid waste collection stream. So we have to look for this segment also. Generally, in Pakistan, we have to consider all these factors in addition to the residential, because there will always be some sort of a construction or a renovation work is being carried out. Now, waste generation rate is dependent on the socio-economic development. If you have more money, generally you will produce a more solid waste. The degree of industrialization, more the industrial products are there, more waste is generated. And the climate also includes the waste generation. Depends on the whether it's cold or hot, rainy or dry. So the waste generation also depends on the climate. The waste generation rate ranges from about 0.5 to 1.5 as an example. But if we look into the specific value, we categorize the waste generation rate from the low income countries is as an average is 0.64, from the middle income countries it's 0.73, and the far high income countries it's 1.64. This high value for the Hong Kong is because of the more quantity of construction demolition waste. Otherwise, it is less than 2 kilograms, 2 kilogram per capita by one person in a one day, as in a collective average throughout the week or throughout the year. So, what factors are influencing on the composition of a municipal solid waste? Geographic location, standard of living, energy source, and the weather. These are the 4 factors. And the composition also includes the location, season, economic condition, population, social behavior, climate, market of a waste material, and like a segregation is being done or not. These factors will change the composition of a municipal solid waste available in the dustbin. Now, if we talk about the composition based on the low income and high income countries, the low income countries have a higher portion of organic waste, higher than 50%, followed by paper, plastic, metals, and glass, and some other. Now, if the categories increase from a low to the mid, the organic waste is reduced, whereas the paper, plastic, and a glass increases. And if we move from a middle to the high income countries, then the organic is further reduced and the paper is further increased. So this shows that the packing material is increased as we go to the higher income countries, and organic waste is lower because food is not being cooked to the high income areas. They generally buy food from the outside. तो ज़रूरी न आहे त उहो उन घर में रेजिडेंशियल एरिया में हुजे, बस पोइ उन में न हूंदो त इहा असां ॻाल्हि कंदासीं त पोइ उन जाइ ते नथो अचे। न जनरेशन रेशियो न ॿुधो, पहिरीं असां इहा ॻाल्हि कईसीं रेजिडेंशियल एरिया जी आहे। रेजिडेंशियल एरिया में ऑर्गेनिक वेस्ट जी सोर्स छा आहे? फूड वेस्ट, followed by organic में ॿिया कहिड़ा कंपोनेंट थींदल आहे? Consider the leaves, yard waste, food cooked हुजे uncooked हुजे, बस यही खास थींदी ना। This percentage is reducing while the income is increased, because the residential people will buy food from the outside. It is not being cooked. So it is not being cooked. So they have a more packing material as compared to the organic waste. A small quantity. Even then, they like if they cook, they use a frozen materials. So again, this frozen material, the quantity is already processed. Frozen material is already processed. You just have to open the packing and cook it. So the cooked food is already prepared. It does not have any peelings that you discard. Only the packing material is there. So organic material, though organic material is there, I don't say that organic material becomes zero, but the percentage of organic material reduces. And for the single story and residential areas and wealthier people will, let's say, wealthier residential areas generate more paper. So this activity not only focuses on the rich countries but to the rich cities or rich areas within any of the country. The trend remains same. Now the densities are given. We have talked about the density. The average density is about 500 kilogram per meter cube. For the waste material, we generally consider the density of a solid waste is 500 kilogram per meter cube. What is the density for the water? What is the density of water? Pani density gani hai? Bari usri 1000 kilogram per meter cube. Means about half of it will be considered as a bulk density. Now if we talk about the density, generally in the municipal solid waste context, we are talking about the bulk density. Or it can be 300 kilogram per meter cube or 150 kilogram per meter cube. Calculated as a low, medium and high income areas. Why the bulk density decreases? For the high income area, the bulk density is 150. For the mid income area, the bulk density is 300. For the low income area, the bulk density is higher. Why there is a difference of bulk density? If you look into the composition, for the higher income countries, the quantity of a paper waste and the plastic is much more high. So they occupy more space as compared to the weight. But as we move to the mid-income countries, the paper quantity reduces and organic increases. The organic contains much amount of water in it. So the organic waste occupies more weight as compared to the same volume of a paper. And if we further move to the low income countries, they have definitely the more organic weight. So the bulk density for the low income countries is higher. It reduces for the mid income countries or the areas and further reduces to the high income areas because of increase of a paper waste. हाँ वॉल्यूम वधीक आहे त बल्क डेंसिटी घटि हुई न वॉल्यूम हिकिड़ी शइ जॻह वधीक थी वलारे उन वज़न पाण घटि आहे त उन बल्क डेंसिटी घटिजी वेंदी आहे इहा हिन में कैरेक्टरिस्टिक लिखियल आहे so 150 kilograms. So these readings are useful while you select the waste container size. For high income countries, if the bulk density comes as an average as a 150 kilogram per meter cube, means if you place a container having the volume of 1 meter cube, then maximum 150 kilograms can be accumulated in it. For the same container, If we place it to the mid-income countries areas or countries, then about 300 kilogram of waste can be placed in that same container. And the same container can also accommodate about 500 kilograms for the low-income countries or areas. This is the concept for the bulk waste that we have discussed in the last regarding the chemical composition of waste. So physical, this part of a bulk waste was actually a physical composition. Now these are the typical moisture contains of these components: food waste, paper, cardboard, plastic, and these are the ranges. A typical value for the food waste moisture content is about 70%. So highest moisture content is available in the organic food waste, followed by the yard waste about 60%, and the wood has also a considerable amount of water content, whereas rest of the other components have a very small quantity of water. So if the waste material has a higher quantity of food and vegetable waste or the wood waste, so the moisture content is high. So these wastes are not suitable for the incinerator. They can go for the composting if the favorable condition is being provided. How we determine the composition of municipal solid waste? We have done work in a practical, and I have demonstrated through the description that how we define it. So what was the mechanism? What was the mechanism? So what was the mechanism? So first method was consider the waste material, and we consider the coining and quartering, and then what was the second step? So let's talk about the it's difficult to write through this. Coining and quartering. Then what was the second step? Take out the material, segregate the components. Like we over here, we have segregated the components, and then weight each of the components. After weighting each component, we take out the percentage through the table. The third presentation is about the chemical characterization of municipal solid waste, in which we have talked about the some testing procedures. We have a solid sample. For the solid sample, we have considered the procedure to determine the moisture content, total solids and volatile solids. Then we have considered the ammonia, nitrogen, the ultimate analysis or the elemental analysis. Then the hierarchical value. For the diluted sample, we go for the pH, total alkalinity and volatile fatty acids. So first we prepare the waste material by using the different types of crushers. This has a jaw, this has a hammer, and this has a disc. So ultimately, what type of a material that we obtain? Such a type of a material. We can sieve the material to the 250 micrometer size. This is especially required while we process the waste material for determining the hierarchical value into the sophisticated equipments. Otherwise, shredding is only necessary. For moisture content, what we do, we place the waste material into the pre-weighted crucible into an oven at the temperature of 105 degrees Celsius for 24 hours, or it can be reduced less than 24 hours. It can be 4 hours, 3 hours, depends on the moisture content. If you have a food waste, then you can go up to 24 hours. But generally, I have shown you that the waste material has a less moisture content, has an average of a 10%. So the 2 to 4 hours are sufficient. And the moisture content will be determined by this formula where we have the difference of masses are there. This difference of mass is actually the weight or the mass for the waste material that we is left, and the M5 is the total mass available for the waste material that we have taken out. Whereas the total solids is to be calculated. So the total solids are to be calculated. 100 minus moisture content will give you the total solids. So this analysis is called the thermogravimetric analysis because the heat is involved and the weight is being lost. So analysis is called thermogravimetric analysis. In the thermogravimetric analysis, we also determine the volatile solid content. What we do, the material after determining the total solids is now placed into the muffle furnace at a 550 degrees Celsius for exactly 2 hours. Now these 2 hours are fixed as per the AFA 1998 standard method, and we determine the volatile solid content through the formula. It again involves the weight mass as in before the place into the volatile solids and mass after the place of solution. The ratio between them is multiplied with 100 in order to find out the volatile solids. The ash content is the mineral content which we can determine for the municipal solid waste while we burn them, burn the open containers. For the volatile solids, we consider the crucibles with the lid cover, so that they do not burn, they only heat it. While if we remove the cover and expose it into the same muffle furnace at the temperature of 750 degrees Celsius for a very short time, say for example 15 minutes, those 15 minutes are sufficient to burn the small quantity of and the remaining will be the content of ash. These all descriptions are available into the practical workbook. Another analysis is the CHONS, the elemental analysis. The elemental analysis, while we talk about elemental analysis, word means elements are to be determined, but other elements can also be determined. Whereas if we are focusing on the CHONS, the basic elements which are related with the organic material, we also call it ultimate analysis. So we have a thermo TJ in which in the crucibles we use diamine and pentoxide, the material will burn out. And we can dilute the sample in order to determine the pH. The dilution ratio can be set at 1 to 10. We can determine the total alkalinity as we determine the alkalinity of a wastewater by the titration method, whereas we can determine the higher caloric value through the Baum calorimeter. In the Baum calorimeter, we take a small sample, place into the crucible at about 1 gram sample, place into the Baum. Baum is filled with the oxygen and placed into the Baum calorimeter, and the heat released by the burning of this material is being calculated by the formula, in which the two temperatures are important. The temperatures before and after the combustion, which actually gives you the raise in a temperature. Higher the raise in a temperature, higher the caloric value. Volatile fatty acids are determined by distillation of the sample followed by the titration of 0.1 molar normality sodium hydroxide, and the phenolphthalein will be used as an indicator. So in this, we first do the distillation. The distillate will be titrated. In alkalinity, we directly do the titration. Here, in the ammonia nitrogen, again we do the distillation and the titration. By this time, the distillation, we have to also add a small quantity of sulfuric acid in the titration. This is the method to determine the material density, not the bulk density. For the material density, we use these glass cylinders. We place the predefined quantity of water and then measure the cylinders before and after placing the solid waste. In actual, what we have to consider, say that we are interested in determining the material density. So the volume occupied by the material and the mass of a material will be considered. We know that the density, talk about the density equals to the mass time to the volume. Mass, how much mass that we have placed into the cylinder, and volume, how much volume of a water raised into the cylinder. So that mass and volume is being divided. By this we can determine the density of a material. That's the material density. Another density, the important density that is associated with the solid waste, is the bulk density. The bulk density, we consider the uncompacted volume. The process remains same, unit remains same, but we do not compress the waste material. Means we place the like we have a predefined container. The volume of a container, this container is predefined. Say volume of a container is 1 meter cube. So volume is there. Now we have to consider the kilograms. How much kilograms can be filled in it? So if we can place 100 kilograms in a container, the bulk density comes out as 100 kilogram per meter cube. If the size of this container is half of the meter cube, and the total mass available in the container is 100 kilogram, what will be the bulk density? 100 divided by 0.5, 200. Yes. So the bulk density is calculated by this way. Density is mass per unit volume, material density and volume density. Now this is the general equation that you have learned since from the school. Now we categorize the material density. While we can categorize the material density, mass is to be divided with the compacted volume or the actual volume covered by the material itself, without considering the voids or the gap between the material. But if we consider the uncompacted volume, we divide the same mass of a material with the uncompacted volume, then we obtain the bulk density. We can determine the bulk density for the larger vehicles by measuring the volume of a storage container and weighting the total weight before and after the unloading. Before and after the unloading, the change in a mass is actually the mass of a solid waste, and by measuring the physical volume of a container, we can determine the density. We can also consider the size distribution. Like we have three sizes of mesh are there. 1, 2, 3. Large size, smaller, and further smaller. So we sieve the material in order to grade them into the sizes. Say for example, the first sieve is 100 centimeter by 100 centimeter. We place all the material solid waste component on the top of it. So the material larger than 100 centimeter will retain on the top, whereas the material which is less than 100 centimeter as in a cross section will place at the bottom. We repeat this process in order to consider the sieves. Like if you have a 3 sieves, so how many friction that we can obtain? If you have a 3 sieve, how many number of frictions that we can obtain? 4. How? 3 passes through, 1 remain on the top. If you have a 1 sieve, we have a 2 frictions. If we increase the number of sieve, so only 1 friction is increased. This is the formula given by the Mushfel and Muller in 1952, that if we represent the organic material in terms of CHONS, a formula, and if we provide some quantity of water in it, and these are the moles of water, then it will produces the methane, the carbon dioxide, the ammonia, and the sulfur. So how much quantity of methane can be produced if the material is exposed to the anaerobic bacteria, anaerobic atmosphere? So I have converted this long equation into this smaller equation. If we have the dry percentage of carbon, hydrogen, nitrogen, oxygen, and sulfur, then we can directly determine the how much quantity of biochemical methane potential can be generated from that waste material. So these are the some characteristics of a CHONS for the different types of agriculture waste, and these are the theoretical BMP that can be generated by considering the formula. I hope so. You have learned how to convert the waste material into the formula in the practical. I think that's a practical 3rd or 4th. Have you done it practical? Not yet. So you will learn soon. You will learn that how the after determining the composition of waste material, you can convert it into the CHONS formula if you have values for the CHONS analysis.